Hi, this is Kevin Trainer, and welcome to part 4 of my tutorial for chapter 8 of the third edition of the Zelle Python programming book. In part 4, we're going to have some fun with games of chance. Okay, and we're going to work with slot machines. Okay, so let me bring in my already baked example and copy it in. And as you can see, it's called Identify Slot Machine Winner. Okay, and it's the tutorial version, so I have that there. And I'm going to open it up. And before I explain the program, I want to explain the data. Okay, so as part of the starter files, I gave you a file called slot values. Okay, and here it is. So it is the equivalent of 5,000 tries at a slot machine. Okay, this is a very simple slot machine. You get 5 values. You know, the old slot machines had the dials, and even the electronic ones try to simulate that sometimes. And so, a really simple thing to try to match would just be colors. So I defined 6 colors, and my 6 colors include red, blue, green, yellow, purple, and orange. Okay, and what I did is I generated 5 values per try. So each of the rows represents a try, and what we see is I randomly generated 5 colors from the range that we had. And so you can see in try 1, I got purple, orange, blue, orange, yellow. So the only thing looks like I got 2 of were oranges. On try number 2, I got yellow, blue, purple, red, blue. So I got 2 blues. On try number 3, green, blue, blue, green, blue. So 2 greens and 3 blues. Okay? And so here's what we're going to do. We're going to take each of these as a try at the slot machine, and we're going to evaluate, based on a given set of rules, which of the tries is the first winner. Okay? And again, I've got 5,000 of these. And in my testing, I changed around the rules a little bit, but I never got to 5,000. I started out with 10,000, and then I cut it down to 5,000 because the test data file was bigger than it needed to be. Okay? So as you can see, these values are separated by space. Okay? All right, so we're going to read one. We're going to say, is it a winner? If not, we're going to read the next. Evaluate, is that a winner? We're going to keep on going until either we find a winner or we get to the end of the file and we said we didn't find a winner and we read so many try lines. Okay, in this case, it would be 5,000. Okay, let's go back and look at the code. Okay, so this is called Identify Slot Machine Winner, a program that reads slot machine results from lines of text and identifies the first winning line. Okay, so it's not real different than the last program that we did. I mean, we're going to be reading lines of text and we're going to be analyzing them, right? But let's take a look. So we've got uh, so we get the name, we get the in file name, right? And we open it for reading. We have the end of file equal false. And then we have, we count the lines. And what we're going to count in terms of the colors has to do with what the rules are. So in my version, okay, in my version, the rules are we we have a winning line if there are 4 purples and 1 yellow. Okay, so there are 5 colors altogether on every line. Okay, so that there could be, it's not at least 4 yellow, 4 purples. I mean, it's exact 4 purple, 1 yellow. And we also have to keep our eye on end of file. Okay, so because we're interested in purples and yellows, we are counting them. Purple count, yellow count. When you do yours, your rules are going to be different. In fact, your colors are going to be different. And the counts that you're looking for are going to be different. So you're going to have to change some of the code. Okay, so let's see. We open the file. We initialize the end of file variable to false. Okay, then we've got a big processing loop. What we're really concentrating on is what the condition is for the processing loop. Okay, and in fact, we'll come back to that. Okay, so if we're still processing, we read a line of input. If we've run out of lines and we hit end of file, we're going to get the empty string. Okay, so then we're just going to set the indicator variable end of file to true. Okay, else we're going to do the work because we haven't hit end of file. So what do you have to do the work? Well, because we've got more than one value on a line, we're going to split it. Okay, so we did a split. Okay, so we created a list called slot values, and we did a line split. And as you can see, we didn't pass an actual parameter or argument to split because we want to take the default. We want it to split on spaces. So we're expecting to get back in slot values 5 strings. Okay, and they'll have the contents with the names of the colors. Okay, so the next thing that we need to do is we need to increment the line count. Okay, and then we need to test for how many purples we have. Now it turns out that it's really easy to ask a list object to count how many of its items are equal to a value. So we just say slot values, and then we call the count method, and we pass it the string purple, and it brings back how many purples we have in that list, which of course is how many purples we had on the line. And then we do the same thing for yellow, so that when we're done, we can see we have properly populated the purple count and the yellow count. So this processing loop is going to continue on until we're done, okay? And we'll go back and revisit the conditions for done, okay? There's really two ways to get done. One way is to win the game. The other way is to get to the end of the tries file, okay? So we're being very polite here. When the processing loop is over, we're going to close the input file. That's a very good practice. And then we're going to say, if end of file, then we want to print no winning slot values found. Because you don't get to end a file unless you had no winner. And then we're going to print line count, lines read from, and then we're going to use the name of the file that we read from. Okay, if we had a winner, we're going to do the else. We're going to print winner found on line, and then we're going to have the number of the line. Now, in both of these cases where we're given the line count, we're going to want it to be, oh, I didn't do it there. See how we have a string of line count? Well, that's what we want here. I had an error right there. That's what we wanted. Okay? So that way it's going to give the line count, and then the period's going to be immediately to the right of it. Okay? And then we're going to want to print the winning line, and of course we don't want it to double space, right? So we don't want to print the new line at the end. So what we want to do here is we want to trim off the last character, which is a new line, and that's what we get with this slice that has all the characters except for the very last one. Okay, so that's the mechanics. Okay, how does the logic work? Okay, well, we have two general conditions that we have to watch. One is end of file, the other is winning the game. Okay, so we say while, while we haven't won the game, and while we haven't reached end of a file, then we're going to want to keep going. Okay? Now, how did I express this with 4 and 1? Well, the way I've expressed it right now is purple count not equal 4 or yellow count not equal 1. Now, did I always have it like this? No, I didn't. Okay, and I'm going to go back and revisit the simplification process that I used to get here after we test this puppy. Okay, all right, and now let's look at this. Not end of file. Did I have to put that into parens? No, I didn't. Not is really very strong, and it's going to adhere to the end of file and be processed with it. But I just thought that I'd put the expression on the left in parens, so I'd put the expression on the right in parens. Okay? So what we're saying here is while we don't have a winner and it's not end of file, keep processing. As soon as we get a winner or end of file, we drop into the work at the end where we're either going to print that we didn't find a winner and how many lines we processed. In this case, it would be 5,000. Or we're going to print we found a winner on line so-and-so, and then we're going to show you the line. Okay? And when we see the line, if we have a winner, it should have 4 purples and 1 yellow. So let's look. So let's give this a run. Okay. And first, let's show what happens when we use an empty file. Okay. If there's an empty file, we're definitely not going to find anything, right? So empty file.text is the input. And we say no winning slot values found. 0 lines read from, sorry, it shouldn't say that. It should say read from. You see, it's always good to test. What's the name of it? In file name. How about that? So I really had problems on that line of code, didn't I? In file name. In file name. Okay, let's try that again. All right. So run it again. I save that. Okay. And this is called empty file.text. No winning slot values found. 0 lines read from empty file.text. That's better. But you know what? I think I want to, let's put a couple of spaces in here. That'll look better. Let's have a period on the end of that too. So here I thought I had it all done. I did it so well. And we're not quite there yet. All right. Try it again. Okay. Give it empty file.text. Okay. No winning slot values found. 0 lines read from empty file.text. Oh, I know why it didn't have a period there. I often find it confusing when you have a file name with a dot in the middle of it to separate the file name from the extension, and then you put a period right after, and it's all in the same typeface. So I'm taking that out. All right. I would say the third time's the charm, but I think it's the fourth. Okay. Let's. So I don't know what we've been doing. Let's run it again. Okay. So let's say empty file dot text. Okay, that looks good. All right, well, let's use the real file. What's the real file called? It's called slot values.txt. Okay. So let's run it again. And let's give it, let's make that a little bit bigger so you can see. So slot values.txt. And we found a winner on line 2120. So that quickly we processed 2,120 lines, and we had purple, 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 yellow, purple. So that's the winning combination. Now, interestingly enough, if these were the rules, and you were at some kind of casino, I hope the payout is awfully big if you have to feed it 2,119 times before you get a winner. Okay. Well, the real rules are different. Okay. They're still not favorable, or it wouldn't be a business now, would it? So that's it. That looks like that worked just fine. Okay. Now, let's go back and take a look at the code up here, the conditions that we're using. I mentioned that I didn't originally have this expression of the conditions, and instead I had a version that I converted using Boolean algebra and De Morgan's one of De Morgan's laws. Okay. And it originally said not condition and condition. And what I did is I changed it to not condition or not condition. Okay, so how did I do this? Well, I turned, this is what I originally had. I had not, and then these were equal. These were equal, and this was an and. Okay, so now I'm not sure what version of this you favor, but I just wanted to demonstrate that you can simplify it in either direction. So purple count equal 4 and yellow count equal 1. That's the winning combination. Okay, so we're going to want to keep reading lines as long as we don't have a winning combination, hence the not. Okay. We want to continue if we have not hit end of file. Okay. So what I did here, let's confirm that we get 2120. Okay. So we're going to run it again. We're going to give it the same test data, slot values.text, and there it is, 2120. So I can't really tell you which version of this is the better version. Okay. The thing is, you might look at this and say, well, I understand this better, and I think that my coworkers will too when I leave it behind. Or you can re-express it, apply De Morgan's law, which means we get rid of the not. Okay. We negate each of the sides. So we say not equal, and we turn the and into an or. So that's applying one of De Morgan's laws. Okay, I think that reads better. Okay, this is a better expression of the conditions in which we want to keep going. Okay, while purple count is not equal 4 or yellow count is not equal 1. So the only time that we're going to stop is when purple count is equal to 4 and yellow count is equal to 1, and that's exactly what we need for a winner. Okay, and I'm just going to run one more test. I like to run a test every time I change code, and I'm going to do slot values dot text, and we found it on line number 2120 again. Okay, so you're going to do something very similar in your exercise. The difference is going to be that you are looking for different colors, okay, and different counts of them. Remember that there are 6 colors altogether: red, blue, green, yellow, purple, and orange. Okay. And so the rules are going to be expressed in terms of the count of 2 colors, and they're going to make up exactly 5 because there are 5 picks on each try. Okay. Remember, slot values look like this: 1, 2, 3, 4, 5. And if you just want to look for the heck of it, if we go down to 2120, 2120 is our good friend purple, 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 yellow, purple. How about that? Okay, so I'm going to turn you loose to do your own exercise, and I'll see you next time. Bye-bye.